Hello everyone, today is day 71 of solving a LeetCode problem every day, and today I'm going to solve kth largest element in a stream. So you're part of a university admissions office and need to keep track of the kth highest test score from applicants in real time. This helps decide cutoff marks for interviews and admissions dynamically as new applicants submit their score. You're tasked to implement a class which, for a given integer k, maintains a stream of test scores and continuously returns the kth highest test score after a new score has been submitted. More specifically, we are looking for the kth highest score in the sorted list of all scores. So we want to implement the kth largest class so that the constructor initializes the object with the integer k and a stream of test scores nums. Then add will add a new test score value to the stream, and then return the element representing the kth largest element in the pool of test scores so far. So for example, right here, we're always looking for the third largest element, and we're given 4, 5, 8, and 2. So once we add this 3, we're going to have 3, 2, 4, 5, 8, and then 4 is going to be the third largest element, which is why 4 is returned in this case. Then once we add the 5, then that 5 becomes the third largest element. So that's why the 5 is returned, and so on and so forth. So there's a couple of ways to do this. I guess like the easiest, most intuitive way to do this would just to be to maintain a sorted list. So like for example, we're given nums in the constructor, nums is passed in. We can just initially sort it, and then every time we add something, we just place it in the correct position, using something like insertion sort, and then we can just return the kth largest element, from the end of the array. And that would be pretty easy, but time complexity wise, it could, depending on what sorting algorithm you're using, it could be like n squared. So let's find another way to do this. The way I'm going to do this is using a min heap. So basically the general idea is we don't actually need to keep track of the entire array. Like there's no point in keeping track of the whole array because we don't need to know what all the values are. We only really need to know what the the top, like the kth largest elements, like what they are so far. So we can use a min heap to keep track of that, because basically the idea is let's say we have like 4, 5, 8, and 2, right? We only care about the third largest element. So essentially we have 4, 5, 8, and 2. We don't really care about this 2 because we know this 2 is never going to be the third largest element because we have 3 elements that are greater than this 2, and we can only perform add operations, not remove operations. So basically, we don't care about this 2. We can just forget about it. So what we can do is we can just create a min heap, and basically 4 is going to be at the root, and then 5 and 8 are going to be children of that. And the idea is the very root of this min heap is always going to have the kth largest element, because for example in this case, so we have 2. If we have 2, 4, 5, and 8, and we don't care about this 2, so if we have 4, 5, and 8, we don't care about this 2, we're gonna have like 4 at the root, and 4 is gonna be the kth largest element. Then once we add this 3, we're now gonna have 3, 4, 5, and 8. But again, we don't care about this 3. It doesn't change anything. It's never gonna be in this top 3 largest elements. So we can just ignore it and return 4 again. But now we get to 5, and this is where things start to change. So we get to 5, and we see that there is a possibility of 5 actually being in the top. Like 5 is in the top k largest elements, because now 5 is greater than 4. So what we do is from the heap, we can just pop this 4 off and add the 5, and now 5 is going to be at the root. So we return 5. So I mean, that's a general idea. Let's just get to coding it. So we want to have a min heap, and we want to keep track of k, and we're going to assign the min heap to be nums, and then k is just going to be k. And then in Python, there's a heap queue class that I'm going to use, and we're going to use heapify to build the heap itself. And we're going to pass in the min heap. And then, so one thing to note is heapify, this runs in O of n time. That's just something you might want to note. And then while the length of the min heap is greater than k, oh, this needs to be in the outside. We want to just pop elements from the heap. And the reason why is like I said before, we only need to keep track of the top k elements, the top k largest elements. We don't care about any elements that are less than that, which is why we're going to pop. And we're pop, so you know, in a heap, when you pop, you're taking out the min. I mean, in the min heap, when you pop, you're taking out the minimum value. So pretty much we're going to keep taking out minimum values until we're just left with k elements. And when we're left with k elements, the value at the root is going to be the kth largest element. So now we're at the add method. So first of all, to add something to the heap, we have to push it on. So there's a method to do that too. And we're going to pass it in the heap and the value we're trying to add. And then we want to check if the length of the min heap is greater than k. And the reason why we want to do this is, you might think, why don't we just, so hold on, let me write this first. So what I'm going to do in here is I'm going to pop the element at the root. So you might ask yourself, why don't we just do this every single time? Because like if we're adding an element, that means we're going to be, that means the heap is going to have more than k elements now, because we just added a new element. So we need to do this anyways. But the reason why we're using this if statement is because what if the size of nums is less than k? That means that the size of the heap is going to have less than k elements. And if that's the case, then we don't want to pop. We want to have a heap of k elements, which is why we have this if statement here. And then we want to return the kth largest element. So again, we just return the roots. So if I run this now, accepted, submit it, accepted. So the time complexity of the constructor is gonna be, so it's gonna be O of n right here. And then to pop elements from the heap, it takes log n time. And we also, so if I do the, let me think about this for a second. So I think it would be something like this. So where n is the size of nums and k is the kth largest element. So I'm saying n minus k because let's say we have 5 element in nums, right? And we're looking for the third largest element. We're going to have to, so it's 5 minus 3, which would be 2, meaning that we need to pop something off the heap twice. And to pop something off the heap, it takes O of log n time. So the time complexity of the constructor right here is going to be n minus k times log n. And then here in the add, the push, so pushing something onto the heap is going to be O of log n. And then over here again, I mean, this is, This can possibly be another O of log n operation, but I mean, either way, it doesn't really matter. And then this is a constant time operation. So yeah, so the time complexity of this method is just going to be log n. And then as for space complexity, so the size of the min heap, it's going to be of size k. But I mean, initially to start, it's going to be of size n, since n is the size of nums. And then, same thing here. We're maintaining a heap of size k. So the space complexity is going to be O of k. And yeah, that's my solution for the day.